Yeah, nice to meet you all.
Nice to meet you, Krasi. Where are you located now?
Sorry?
Where are you located?
In Bulgaria, same as Christo.
Okay.
And what about you?
I'm located in Italy today.
Oh, nice.
Oh, today.
By the way, are you coming for the event on the 29th?
Yeah, definitely I will. Yeah. I'll come to Bulgaria. Yeah.
Do you know who else is coming?
Christian will come.
Yeah. Okay, we're live on YouTube.
So I probably fly with him.
Okay, YouTube works. Maybe we can stop it now.
Okay.
Darren promised to attend as well.
Oh, now it's just me and Krasi visible on YouTube, and we have 10 people watching us. Hi, guys.
Super cool.
Shall we leave it like that, or we should stop it right before we start?
What do you mean? Or you are saying that we should start before when we start, right?
No, shall we stop the YouTube streaming?
You mean right now and start at 6 p.m.?
Yeah, definitely.
It makes sense to stop streaming right now. And I also need to record this, right? Or will it be recorded on YouTube?
Yeah, it should be recorded on YouTube. It's
Let's
already recorded.
I think that, but if you can if you can press the record button, I think it won't. At least you will have also in
the chat and questions, right?
Zoom. Yeah. Because it's actually Q&A. They are very valuable, because then I just take them out separately.
Okay, so Max, don't forget to hit the record button.
Yeah, sure.
Max, do it now. Because then it's usually when we started in several minutes after.
I would recommend not to stop stream right now to don't have any potential issues. So just for upcoming session, we will start it like at 5 p.m. Polish time exactly. Okay, and let me start record right here. And I think that we should agree that the priority of questions should go from the Zoom and after that from YouTube.
Yep. You know what? Look, it's actually wait for a second. Here's a
We can
section.
disable YouTube questions, maybe.
Wait for a second. Okay, I'll do it like this. So people will upvote, right? And then you go with the most questions. And I didn't allow anonymous questions as well. Okay. Cool, guys. I have to leave, but I come back like in a half an hour or something like that. Could you please move me to the Losha, could you please revoke my my host rights so I will not be here on this panel list?
Max is the host right now.
Max, could you please revoke my co-host rights?
I think that you can just leave, and when you rejoin, you will be
Oh,
automatically
okay.
assigned as your host.
Okay, guys, and I wish you the very best and the best good luck during this session.
Thank you, Elena.
Thank you.
Thank you. Bye.
Bye.
Hello, everyone. We can wait for another minute and then we can start. I see we already have more than 80 people here attending. And the number is growing quickly. So I'll wait until it becomes more stable. So maybe we're ready to start. Just 1 more minute. Let's see if numbers are still growing as quickly as it used to be. Okay, it looks like almost everyone is here. All right, guys, welcome everyone. This is lecture 1 from our blockchain course. That's an internal course that we are going to do for Exadel. For those who don't know me, my name is Christo Pev, and I'm the founder of a company called Motion Software, which was recently acquired by Exadel. And now I'm transitioning to the position of EVP of Innovation at Exadel. Here we also have my partner and good friend, Krasimir Raikov, who will introduce himself.
Hey guys, nice to meet you. My name is Krasimir. As Christo mentioned, you can call me Krasi. I've been in the blockchain space for the past 6 years, mainly focused on developing applications on top of it, mostly on Ethereum compatible chains. So yeah, I think that's a quick intro for me. So I'll be handling most of the technical parts in the course. I'm going to show you some live demos or some technical details about what Christo is going to talk about. So yeah, nice to be here.
Thanks, Krasi. So as Krasi mentioned, our lectures will consist of 2 parts. We have 4 lectures that will be performed over the next 4 weeks. This is the first one. And today we'll outline what we're gonna talk about in the next 3 lectures. So for the ones who are not sure if that's for them, now you have a great opportunity to learn more about the topics that we're going to discuss. And the main topic is DeFi, or the so-called decentralized finance. The underline of the whole course is the future of finance is decentralized, and it will represent a quick dive into the world of DeFi. It's quick because the world of DeFi is gigantic. It's enormously huge. There are thousands of protocols, decentralized applications, and other programs, projects, teams developing a technology which most probably will be quite popular in the future, the same way as things like electronic banking are popular today. So today's agenda, I would say today's the easiest lecture, as we will not focus that much on any specific topic, but we'll do an overview of the whole DeFi ecosystem and what are the most popular applications and projects there. We're both, me and Krasimir, we've been both consultants and software developers for many years. I started my career in asset management few years before blockchain became a thing. Actually, blockchain became a thing, at least for me, around 2016 when Ethereum was released, and Ethereum was the first fully featured blockchain network that allows smart contracts to be implemented and deployed. And smart contracts are really a game changer because they enable us to use the blockchain not just for sending and receiving money and have like a basic wallet or basic banking system, but smart contracts allow us to create entire applications. So today we'll talk a little bit about how these technologies actually already changing the world. What are wallets, smart contracts, and dApps? What's the meaning of the term DeFi, why it's important, and we'll have a deeper look at 4 popular DeFi applications, which are trading to automated market makers, using stable coins and algorithmic stable coins, lending protocols, and of course, NFTs, something which is super trendy at the moment. We'll look at the risks associated with this technology and also how to be part of it. Actually, we'll have also a practical exercise led by Krasi. So we'll show that it's actually not that hard to create applications and to make websites or mobile apps who are connected to the blockchain. You can ask questions all the time. Of course, most of them will be answered at the end. You have this Q&A feature on Zoom, so please use it. I'm not sure if the chat is working. I see it's working as well. So yeah, don't hesitate to ask questions. It will be, that's for us the great way to understand actually to what extent we explain well this topic. All right, so the blockchain, as probably most of you know, is this system of millions of computers sharing the same memory and executing the same procedures at the same time. This parallelization of the execution guarantees that only one thing. It guarantees that the information that they process is the same, and it guarantees that if one of these computers tries to change that information or misrepresent that information, that computer will be excluded from the whole system. So we can trust the whole system. And obviously, the main point of using blockchain systems is to use systems we can trust on, systems that we know that no one can change the data written in them, or no one can change a behavior that we implement there. There are many different blockchains, like the most popular one is Bitcoin, the first one, which is not that fully featured. Then it came Ethereum, which is pretty much the biggest at the moment in terms of users, applications, and so on. And then we have many other projects that we are not going to talk that much about in these lectures, like Solana, Polkadot, Avalanche, Tron, and so on. All of them have advantages and disadvantages, but the key thing to know here is that pretty much 80% of everything that happens in the blockchain space and 80% of everything that happens on DeFi happens on the Ethereum chain. And that's why we're going to look at the Ethereum chain. How blockchain is changing the world. There are like few unique features that make this system superior to what we used so far. The first one is that there is no centralized control, which means that all accounts, balances, users, transactions stays on the shared memory of this system, and no one can modify it except its owner. Even the owner cannot modify it. Actually, the owner can only write something new on top of the old version of the information that has been provided. and thus show a new version of it, but all old versions will stay there. Once you put something on the blockchain, it stays there forever. And this is one of its core features. There is no limitation of access. This system is available 24/7. Even some of the nodes, that's how we call the computers that run this system. If even some of the nodes are not available, there are lots of others that are. So they guarantee that this system is working 24/7. And actually, for the Ethereum blockchain, that's absolutely true. It never stopped since long time. Actually, it stopped once in the end of 2016, and that was a huge event for the ecosystem because Ethereum split it. The network was forked into Ethereum Classic and Ethereum, and it stopped because of a bug. But since then, the Ethereum blockchain has never stopped. So we've been able to rely on that system all the time. There is no need of managed exchanges and transaction facilitators because everything happens inside programs. So we don't need middlemen to guarantee that some money will be transferred from here to here, or that a promise will be executed, since all these things become open source programs that anyone can analyze, read, and also inspect the behavior of these programs after they executed various functions. And that's exactly the fourth point here, opacity. We can see everything that happened, although we maybe don't know who is the owner of given wallet or given transaction, because owners are identified by public keys and there are no names behind the public keys. We can see everything that happens between these public keys pretty much. And this is great because it guarantees transparency and availability of all the information to the public. And there is no need of customer support simply because nothing breaks. And there is no customer support. So how to use it super quickly? Maybe many of you know you need a wallet. The wallet consists of two key components. You have your public key, which you can share with the world. You have your private key. Your private key is something that anyone with it can access your assets or can call smart contracts and their belonging functions on your behalf if it gets stolen. It's very important where you keep your private key. And for the purpose of this lecture, we'll keep our private key in a plugin called MetaMask, which is a non-custodial wallet. It's important to use non-custodial wallets because they give us access to the actual power of the blockchain. Like we cannot call smart contracts with wallets in Kraken or Binance and so on, the so-called web or hot wallets, since they don't allow us to actually access our private keys. Although we can use all other kinds of cold wallets, hardware wallets, where we have access to our private key to interact with the blockchain in an efficient way. So what are smart contracts and dApps? dApps is an acronym for decentralized applications. And dApps are actually very similar to the applications that we can find in our mobile phones, for example, or like on our PCs. The main difference is they don't run on one device. They run on these millions of computers, the blockchain. And thus, each line of code is way more expensive to execute. What are the features of these applications? That's exactly what we're going to talk about, but they're getting closer and closer to the features of the applications we used to see in our phones. The meaning of the term DeFi, decentralized finance. This is a system by which financial products become available as decentralized applications, making them open to anyone to use rather than going to middlemen like banks or brokerages. Essentially, the applications that you can use in your bank, the services you can use there, good examples are, let's say, checking and saving accounts. You can borrow money. You can insure your car, your house. You can do analytics on your financials. All these applications are already available on the blockchain. And they're not owned by a bank or by any institution, and they cannot be controlled by a bank or any organization or individual. Because once these applications are deployed on the blockchain, they live there forever and anyone can use them to make transactions, to interact with them in a super transparent way. Because, for example, when you go to your bank, you have no idea how the yield, the annual yield is generated, like the interest rate that they pay to you. You know, they tell you we give loans, we trade your money and so on and so forth, but you can never be sure what they exactly do. While here you can trace every single cent of your money and how exactly yield was generated if you put your assets into yield generating contracts, for example. There is a nice website called DeFi Llama, where you can see all the biggest applications in terms of usage and total value locked. And currently, actually, this is not the most current state. This is maybe from a month ago. We can open like to see in real life what's going on there. So currently we have MakerDAO as the biggest DeFi applications with total value locked of $8.12 billion US. And then we have some others like Lido Finance, Aave, Uniswap, Curve, and so on. Luckily, in our lectures, we'll have a deep look at MakerDAO, Aave, Uniswap, Curve. We'll learn how they work, what they do, and even how to create products like protocols like them. They call them protocols simply because they're open source programs available to anyone. So this website is a great source of information for what are like the most trending DeFi applications. And you can see that as the App Store on your phone, pretty much. Like here, the links to all these applications. So for example, in MakerDAO, I can from here open the website and start using this decentralized application. And now we're gonna talk about it, how it works. As we can see here, there are different blockchains listed. Here you see Ethereum, BSC, this is the Binance Smart Chain, Tron, Solana, Avalanche, I just mentioned a few of them. And we can see the analytics for each of them. So you can see at the moment in Ethereum, we have 32.5 billion total value locked, while in the second biggest blockchain, Binance Chain, we have only 5 billion. Then Tron, Solana, and so on. So as I told you, 80% of all the action is happening here. And the good thing is that many of these protocols, thanks to the Ethereum virtual machine, many of these protocols are supported not only on one chain. As you can see, for example, Uniswap, it's supported on the Ethereum blockchain, on Arbitrum, on Polygon, on Optimism, SEO, and others. And this cross usability, you can compare that to like running your app on iPhone and your app on Android. It's we can do that kind of analogy. although the different blockchains have actually bigger differences in terms of performance, in terms of features than the operating systems of our mobile devices. The ecosystem of Ethereum is extremely huge. As I told you, there are thousands of projects. They're also categorized in different categories. We have stablecoin protocols, we have services, we have infrastructure and dev tools, asset management tools like the wallet we're using, and also exchanges, lending protocols, NFT protocols, things that are even not visualized on this chart. And now we'll directly jump into the actual applications. So one of the first things that became successful as a decentralized financial application is trading. So at some point in 2019, I think, 2020, the concept of automated market maker appeared. Actually, it appeared out of a publication of Vitalik Buterin, who is the creator of the Ethereum blockchain and one of the co-founders of Ethereum. He published the idea of creating a new kind of an exchange. So on the left-hand side, you can see how a traditional exchange works. Traditional exchanges, even exchanges like the London Stock Exchange or the New York Stock Exchange, NASDAQ, also exchanges like Binance, centralized crypto exchanges like Kraken, Poloniex, Bittrex, all of them work using the concept of the open order book, which means that all people that want to buy a given asset compete with all people that want to sell a given asset, and they actually publish their orders inside these order books, and there is a matching engine which matches the orders and executes the trades. So for example, it's not important what is the asset. Let's say it's Bitcoin. So the current market price of Bitcoin is $400 US. And you see this guy on top, he's willing to sell 21 Bitcoins. And on the other side, to buy 21 Bitcoins. And on the other side, we have people looking to sell these Bitcoins. And that's how the whole trade happens. Like, for example, this guy is looking to sell 9 Bitcoins, and probably the buyer from the left side will buy these 9 Bitcoins plus few others until he fulfills his order. And that's how exchanges used to work for maybe 70 years or even more, even in the non-internet world. In the world of DeFi, we have something called the automated market maker, which completely changes that concept. So we don't have order books, we have liquidity pools. What are liquidity pools? There is one big inefficiency with the open order book exchanges. Always when you list an asset, let's say on the New York Stock Exchange, you should also provide market making, which means that you need to execute trades even though you don't want to do them, because you need to keep the market liquid. You need to keep people being able to buy your stock at any point. And the automated market makers pretty much solve this issue without requiring complicated market making, which typically happens to algorithms and like bots that set a specific price, set specific quantities, and so on. So they keep always the order book filled with orders. So the automated market makers, they enable people to stake their assets. You always stake an equal portion of 2 assets. So here, for example, that guy is taking DAI tokens and Ethereum. The DAI token represents the USD dollar, yeah, the US dollar. Like one DAI token is always equals $1. So for example, let's say the price of Ethereum is $1,000. I can put in that program, that's a smart contract on the blockchain. I can put one Ethereum, one Ether. Actually, that's how we call the currency in the Ethereum blockchain. So I put one Ether and $1,000 simultaneously. So other people can come and use this money to trade. So for example, there is another participant who wants to buy Ether. So he comes to this pool and he extracts some of my Ether, adding more DAI tokens. And the people who put their money inside these pools are called liquidity providers, because they also make some fees for each transaction, and that's how they are incentivized to provide liquidity. This is an extract from Uniswap, which is the biggest decentralized exchange based on automated market makers. And on the right-hand side here, you can see what are the liquidity fees. So for example, for the Ether and USDT pair, we have 28% yield, which means that if I keep my Ether and USDT staked in that contract for 1 year, I should make 28% profit on the amount that I have staked out of fees that people pay when they come here to trade. And this is one of the most popular ways of creating value on DeFi, and there are people who professionally find that kind of protocols to stake their assets in order to make yield on their assets, and at the same time they make markets efficient. Good feature of this decentralized exchange is that it's completely decentralized, which means that you don't need like to register here. You don't need to go to KYC. You don't need to rely on a third party, because this is just an interface connected to the smart contracts on the blockchain. Basically, the back end of this thing is not a server, it's simply on the blockchain, and we fetch this information from the blockchain smart contracts. So there is no risk of Uniswap manipulating my transactions or locking my money, as very often happens with the traditional centralized exchanges. How we discover the price, that's an interesting question. Actually, maybe Krasi can join here and talk a little bit about that.
Yes. So basically, as Christo mentioned, the way liquidity is provided is into pools. So instead of making trades between people, and instead of having a single place where all the market orders are combined and executed, you basically trade against a program. And the way the program calculates the current price is based on this simple formula. So you have X multiplied by Y, and it should always be equal to a constant number. So if you take some amount of the first pool, then immediately the price is adjusted, and the amount of assets that you can take from
Hey,
the
Krasi, we don't
first
hear
pool
you. Do you guys hear me? The rest of you?
Smaller for the amount that you are going to pay from the second pool.
I hope you.
Krista, I can hear you well.
Hi everyone.
Something-
Sorry. Yeah, I dropped for a second.
Yeah, me too.
Okay, I think everyone dropped for a second.
Ah, okay, cool.
I don't know.
I
Maybe
mean,
the rest
not
can
cool, but
confirm.
yeah.
Yeah.
Uh,
Okay,
okay. What
let's
was the last thing
continue.
that?
We talked about how price discovery works according to this simple formula. And what are actually automated market makers good at? They're very efficient to implement in smart contracts, very easy actually to deploy and operate. We can always quote a price there, even without having active market makers, because we have liquidity providers. Our order book is infinitely deep, because simply our price will go infinitely high if we lack one of the assets there. They work 24/7, and there is a big problem there. They're extremely capital inefficient, something which we're going to talk about in the next lecture, which focuses entirely on automated market makers. The next interesting topic is stable coins on DeFi. And actually, probably you've heard about stable coins like USDT, USDC, which are pegged to the US dollar. And they're not only pegged to the US dollar, they're backed by the US dollar, which means that for every USDC you have out there, there is $1 US locked in some bank account. The case with the DeFi stable coins, it's completely different. Here we don't have any US dollars, actual dollars locked anywhere. We have the so-called algorithmic stable coins, which means that we have money which is pegged to the US dollar, like the DAI token, which always worth $1 US, but it's backed by other cryptocurrency. So how that works, like I can go to this protocol MakerDAO, and I can stake, I can lock my Ether inside a Maker Vault, which will allow me on the other side to withdraw USD tokens, like DAI tokens that equal the American dollar currency. To show you like a better, like in practice, how that works, I will directly go to the page of the protocol. So here you can see we have these votes. We don't want to multiply, we want only to borrow, which is the basic feature. So this is the ETH vote, and it says that with 159 ETH, you can borrow up to 150,000 DAI tokens. That means that if I have 159 ETH, I can lock my 159 ETH inside this program, and I can borrow $150,000, and I can use them in a way I want. And the good thing is that I still have my ETH. It's simply locked here. And if the price of ETH is going up, I will be fine, because I can pay back my 150,000 DAI tokens, and I will get my ETH back. If the price of ETH is going down, I can be in a trouble if it goes too low. And the exact level is 170% collateralization, which means that if I have borrowed $100,000, I need to have the equivalent of $170,000 in ETH at least, in order to keep my vault open. If the price of ETH goes down and it goes below 170,000, the program will liquidate my ETH automatically to pay back for these 100K that I have borrowed, and the rest of the ETH will be sent back to my wallet. You know, there are many services like Celsius, Nexo, and so on, where you can do the similar thing, but they're like centralized systems, while here you can do the whole thing to a program that you can really trust and analyze, which is simply revolutionary on its own. So this is the example, and to get back, as I said, our ETH, we use the DAI tokens that we withdraw, we send them to the smart contract, and we unlock our collateral. And this is an example of pretty much the first and still the biggest lending protocol on Ethereum, which provided access to isolated lending markets, which means that for one digital currency, you can withdraw only one stable coin. A little bit later, we've been introduced to a better system, not better, but different, and I would say more efficient. It's called Aave. It's also insanely big project and very famous. Aave is based on lending pools, not just on isolated lending markets, which means that you can deposit your entire portfolio of tokens on one side and withdraw different tokens on the other side. And we'll have very deep look at it in the next lecture, but pretty much provides the same feature. Why is it good?
Sorry, Christo, for the interruption. Since we are on the MakerDAO and we already passed MakerDAO, there is a question about MakerDAO, so maybe now it's a good time to answer it.
Absolutely.
So one of the use cases of MakerDAO, that's a very good question actually, because I'm not sure how good is is the explanation itself to explain the use cases. So once I met a guy from Argentina and he basically bought a house through MakerDAO. So that guy has ETH, but he doesn't want to sell his ETH to get dollars and buy a house. So basically he walks his ETH into the protocol and he takes dollars in return. So he uses the dollars to buy a house, and then he can repay the loan to MakerDAO and get his ETH back. The worst thing that can happen is that the same person can lose his ETH because that's the collateral. So if you compare it to the traditional world, this is like taking a loan from the bank, but instead of collateralizing ETH, you are basically collateralizing your reputation, your house, or whatever you have as a real asset. So yeah, one of the use cases is that you can take a loan out of MakerDAO, do some stuff with the money, and then you can repay it back.
Yeah, it also has an interest, which is very low, depending on the collateralization ratio. But if you choose the high collateralization ratio, which is 170%, your annual interest on your loan is just 0.5%.
Yeah. And another use case is, again, can be compared to the traditional world. There is this thing called leverage in the finance world, where you can basically loan money from someone to trade with more money. So imagine that you have 100 ETH and you use MakerDAO to take a loan in DAI. So you deposit 100 ETH and take, let's say, $100,000. Then you can buy more ETH with the DAI that you have. Then you can lock it again and take more DAI, and then you can lock it again and take more DAI. And at the end, you will end up with a lot more money that you initially started with.
But you also have a huge risk if the price of it goes down.
Risk. Yeah, it's like a compounding risk. So yeah,
Oh.
this is mostly, I think these are the most used use cases.
This is the most close equivalent to the loans that we're used to see in the traditional world. Like we stake our house, we lock our house with the bank, they give us money. When we pay back the money, we give our house back. The thing is that it's fully automatic and it's a program, it's not a bank. So this is why it's so innovative and interesting. We'll talk a lot about the benefits of such systems, but in general, they're more efficient. They have lower overhead and you can trust them more compared to the traditional ones, especially if they're not established ones. The next application of the DeFi, and actually it was not considered DeFi until recently, but since lots of money were poured into NFTs and lots of organizations started using NFTs as financial instruments, now NFTs are officially part of DeFi. You've all heard about NFTs. They started as these animated profile pictures on the internet, and also animated cats that you can go like Tamagotchi or simply to collect as a picture. And now they're turning into more and more complicated. They're used in more complicated scenarios. So for example, one good scenario is the scenario of the Fly Fish Sushi Club. This is a restaurant, I think in LA or somewhere else in the States, that is selling memberships to NFTs. So I have two kinds of memberships, like the basic Fly Fish membership, which costs 2.5 ETH, or I have the Fly Fish Omakase membership, which is double that price. And if I have that membership, I can actually attend the physical restaurant. Otherwise, they will not let me in, because this restaurant is designed only for people who bought that membership. And at the same time, the restaurant, it's still even in construction. So the company used that NFTs sale to basically fund the development of their business. And then the people have no equity, no stock in it, but they have access to it. And that's why these NFTs are called like utility tokens. They have some utility, but they're not security. And in most of the cases, they're not security simply because it's really not legal to sell securities on the internet that way. Another great example are the NFTs sold by companies like Nike, Louis Vuitton, Dolce & Gabbana, and so on in the last few months. Basically, Nike sold NFTs for $185 million since April this year until now. And they sell them the same way they sell shoes. They sell them as products. And it's like shoes, but shoes that I put on my Instagram page and my Facebook page rather than on my feed. But the effect is the same. I show to all my friends that I have some fancy, expensive shoes, and I'm the coolest guy in the room. So many companies started using NFTs as a symbol of wealth, symbol of being significant. Another very interesting usage is in games. Here on the left-hand side, you can see a screenshot from a very popular game called Axie Infinity, where NFTs are used as creatures. You can actually mate these creatures so they have their babies, and the babies could be sold as NFTs. And basically, NFTs are turned into digital assets in a game. There are more interesting trends coming here, like tokenizing real-world assets like cars, expensive paintings, and so on, and people buying them and trading them as NFTs, which makes the whole process way more efficient because you don't need to go to auction house or any intermediary to be sure that you are buying an expensive painting, for example, or an expensive car. Those NFTs are traded on exchanges. OpenSea is the most popular one. It is similar in concept to the exchanges where you can trade other digital currencies, but simply designed for pictures, pretty much. And now there is a new trending thing called SudoSwap, which adopts lots of concepts from DeFi protocols like Uniswap or MakerDAO that we have just looked at, and enables people to trade NFTs in more efficient way, to provide liquidity with NFTs, and so on. So what are the risks associated with these kind of smart contracts and decentralized applications? The first risk is the actual smart contract risk, which means that there could be a logical error in the code of the contract or an economic exploit which was designed by its developer, or an attacker can identify an exploit and basically steal whatever assets are locked in that contract. There is custodial risk, which means that you can lose your private key, or someone can steal your computer where your private key is saved, or someone can steal your notebook, physical notebook where you have written down your private key, and access your assets that are staked on DeFi or somehow processed there. There is a scaling risk. The blockchain technology, as you all know, is still experimental. So we see that it's working at the current state of Ethereum or the other blockchains, but we're not sure if it will be working once we have 100 times more users or 100 times more nodes, since blockchain itself is quite complicated system and depends on many factors that, of course, people are trying to predict. Now with all these updates, they're trying to make it more secure, but we still have these scaling risks. And one very important thing, which is in the context of automated market makers, these new ways of trading, it's called impermanent loss, which means that although you have staked equal portions of your assets there, let's say 1 Bitcoin and $20,000 as a liquidity provider, you can still lose money if there is a rapid fluctuation in the price of Bitcoin. Because automated market makers are not super efficient to prevent problems with such fluctuations. And that's also very long topic that we'll talk about a little bit more in the next lecture. And here we reach the point where we ask the question how to be part of DeFi, if we want to be part of DeFi. So there are several ways. As you know, there are lots of resources on the internet. There is also a list of resources that we'll publish here. It's at the end of this lecture, of things like websites, video tutorials, and so on that are extremely helpful. You can also talk to people who work on DeFi projects, because that's a community-based network, and like the network effect is super important in the world of blockchain, crypto, and DeFi in general. You can learn how to develop smart contracts, and you have the opportunity to do that if you stay in the next part of this talk today. And you can invent and deploy new token economics and protocols, which is pretty much like the product, the equivalent of the product management activity, product management profession in the traditional software development world. So if you guys want to be part of DeFi and learn how to create smart contracts, how to create your own protocols like MakerDAO, like OpenSea, and so on, you should better stay for this, for what's next and for the next few lectures. And here I will give the word to Krasi, who tell us a little bit more about the Ethereum virtual machine and why actually it's pretty much the most important thing that we have on DeFi at the moment.
Okay, thank you, Christo, for the nice explanation of everything. Can you guys hear me well? Yeah,
Yep.
I think so. Okay, cool. So before getting into what the Ethereum virtual machine is, I'll get a little step back and tell you first how the whole blockchain works, because I saw that there are few questions about the networks and how they operate and how they are bootstrapped. So before getting into that, I want to spend some time to get into the basics and the foundation. So basically, as Christo explained, the blockchain is basically a network of multiple computers called nodes, and they operate under the same rules, under the same algorithm, if you want. So they have this thing called consensus algorithm, which is basically a way to prove that a certain thing is correct, or more like to prevent people from messing with the data and including invalid or malfunctional data into the chain. So each of these nodes can verify transactions, and they can include and batch these transactions into another piece, which is called a block. So each block contains of multiple transactions, and these transactions are identified by a hash. The hash is basically a hash of all the transaction data, and each block has also a hash. So two blocks are connected through their hash. So block 2 has the hash of block 1, block 3 has the hash of block 2, and that's how they are connected. That's a really quick explanation. There is a lot of information already on the internet on the technical details, how they work. This is not the focus on the current course, but I really wanted to include that for a bit. So what is the Ethereum virtual machine? That's basically a virtual machine like let's say the Java virtual machine. And the interesting thing is that the Ethereum virtual machine is basically on every computer, on every node that is running the Ethereum blockchain. So every node can execute operations on the virtual machine. So that's basically how the smart contracts are executed. The smart contracts are written in Solidity. That's a language specialized for developing smart contracts on the Ethereum virtual machine. So the Solidity compiler is compiling the Solidity code, and it's producing bytecode that is understandable by the Ethereum virtual machine. And another important thing to say is that it's Turing complete. So basically, if you have enough resources and you have enough time, you can computate basically everything. So there is one question that it always comes when we talk about smart contracts and the virtual machine. And the question is, how do we prevent people from running infinite loops? Because that would basically make all the nodes in the network unoperational, and they will be basically a denial of service attack. So the way this is prevented is by introducing the gas. That's basically the energy that's consumed by each opcode by each instruction that is executed by the virtual machine, and there is a limit to that. So in every Ethereum block, you can have that much gas, which will prevent people from running infinite loops, because each cycle of the loop will cost some gas. And since there is a limit to that gas, you cannot execute infinite loops. Also, in order to incentivize the node operators and the miners and the validators to validate transactions and to make blocks and include them in the chain, people that are transacting on the network pay transaction fees. And in Ethereum, the transaction fee is calculated by multiplying the gas price by the number of gas that is consumed by your transaction. So let's say that, and the gas price is defined by the network itself. So each miner can say how much gas they want to, how much fee they want to receive in order to include your transaction. So you have to pay that amount multiplied by the energy that you are wasting and the computational resource that you are wasting or using. So yeah, I think that's a good explanation of how the contracts are executed and how the Ethereum virtual machine works.
Here is a great moment to mention that there are other big blockchains who support the Ethereum virtual machines, which means that once you write a program a smart contract that works on Ethereum, it can also work on Polygon, on the Binance Smart Chain, on Phantom, Avalanche, and so on. And actually, this is great for the blockchains because they manage to find users more quickly compared to blockchains that have their own languages and their own virtual machines, which are blockchains like Solana, like Cosmos. And on these blockchains, like the learning curve is way higher and longer. So people that are used to Solidity and the Ethereum virtual machine won't be that comfortable with the other blockchains. And I would say that Ethereum virtual machine is currently keeping 90% of the market share there.
Yeah, and I think the reason for that is because it was the first, blockchain that allows executing programs. That is the smart contracts on the network is the Ethereum chain, and because they were first, the number of usage and adoption of the Solidity language and of the way Ethereum virtual machine works is extremely high. And I think it's like really hard to break that cycle, even though Solidity is not that great and many people are complaining of it, just because it was the first and just because there are more than 200,000 developers at the moment. I think this will be the thing that will remain in the future.
So here you can see a snippet from a Solidity program. As you can see, the code is not. Kasi, do you also see my screen?
Yes.
Okay, perfect. As you can see, the code is not that different from what we used to see in JavaScript or other functional or object-oriented languages. Actually, they designed Solidity in order to be a simple language and in order to attract people to use it. And maybe Kasi can say a few words about what is this program doing. And
yeah, so Solidity is, I think it was based on Python or close to how Python syntax is. I'm not a Python developer, but that's what the Solidity documentation says. So this program basically have two functions, as you can see, function for deposit and function for withdrawal. So basically the deposit function requires requires a message value, which is a special symbol or a special
Keyword.
that's right. That is basically saying this transaction should come with ETH along with it, and that ETH is going to be deposited into the contract. From the example of MakerDAO, when you have to deposit ETH into the contract, this is the same. So the message value is the number of ETH that you are sending with the transaction, and that ETH is going to be remained in the contract. So the contract, when the contract gets deployed on the network, the contract is deployed on certain address, and that address points to the bytecode of that contract, and that bytecode is stored on every machine that's operating the network. So when you want to interact with the contract, the only thing that you need is the contract address and definition of the interfaces of the contract, because in order to interact with them with the functions, you need to know the function signature, which in that case is function deposit, and in the withdraw is function withdraw, accepting one parameter. So you need this data in order to interact with the contract and execute the functions. I think on the next lecture, we'll get into more details about Solidity. So this is just a snippet. So the deposit function is, as I said, depositing ETH, and the withdraw function, firstly, on line 9, it checks whether the balances that are managed by the contract for that user is enough to be withdrawn, because in the deposit we have increased the amount of ETH that the user has deposited into the mapping. As you can see, the mapping is just like a dictionary, and the key to that dictionary is the address of the user, which is defined by message sender. Just like message value, we have message sender, which is the address that has executed the transaction. So if you have a wallet and you create a transaction, and that transaction is interacting with a contract, your address of your wallet will be stored inside the value of message sender. So we are basically keeping a mapping, and the key is my address or the user address, and the value is the value that they are depositing. So whenever the user wants to withdraw, we need first to make sure that the amount of ETH that they want to withdraw, they have already deposited, and then we are subtracting, and on line 11, we are sending to the message sender the amount that they want to withdraw.
And the most important thing here, I would say, is that once deployed on the blockchain, anyone can call these two functions as their public functions. And you just need to pay your gas in order to do that. So that's like an open source program, which is not just readable by the people, but anyone can use it without hosting it elsewhere. And now we come to the point where actually Karasi can take over the sharing, and we'll show you how we connect a regular web application, like a simple React application, to the blockchain, which is, of course, one of the key requirements to have the so-called Web3 application. Think like the Web3 applications are getting very popular. So we will learn how to create our first one today. I see there is
in order to yes.
No, I saw that there is a question regarding some good sources. Here they are. I will copy them and send in the chat after this. So I will stop sharing so you can share your screen.
Yes, thank you. So first, let me demonstrate you what we are going to do, and then I will explain why and how we are doing it. So as Christo said, this is a simple React application which will connect to an external wallet, and it will allow us to make transactions to the Ethereum blockchain. In the demo, we are going to use a test network. A test network is basically a blockchain network that doesn't have any real value into it, so people can interact with the chain freely without the need to pay any fees with real money. This is like a, let's say, development environment or staging environment or something like that. So we have basically two buttons. The first button is connect and the second button is send. The connect button will make a request to a browser extension, which is called MetaMask. And whenever I click connect, I will be prompted with the available wallets that I currently have that my application supports, and I can choose from a list. Later on, we will add more options to that list. So whenever I click MetaMask, the application will check if I have the MetaMask browser extension installed on my browser, and if it does, it will connect to it. Now I will explain what MetaMask is in a moment. Let me just forget my connection so I can show you the full the full flow of how this is going to work. Okay, I guess they have moved the
Okay. Can you open three dots against your specific account? Can you close settings? Yeah, three dots, and there is connected sites.
oh yeah, connected sites. Okay, yeah, thank you. So basically, MetaMask is keeping my connection, so I don't have to accept it every time. But yeah, I want to show you the whole flow. So whenever I select MetaMask, MetaMask is asking me how many of my accounts I want to connect and give permission to the dApp, to the application to use. So if I choose both of them are going to give access to the application to interact with those accounts. So yeah, now I'm connected with my first account. And then the send button is basically interacting with MetaMask and saying that I want to send 0.1 test ETH to my second address. And if I confirm that transaction, a transaction will be broadcasted to the test network of Ethereum, and all the miners of that network are going to verify the transaction and include it in a block. So this is a block explorer, which it's called Etherscan. It allows us to browse transactions freely and check all the network activity. So here we can find every single transaction that happened ever since the first block. Every single block, obviously, and every single interaction with the contract. Basically, everything that ever happens on the chain can be observed from here. Now we can see that the transaction is already successful, and here are some details like the transaction hash. So this is the identifier of my transaction. So if I want to check what my transaction is, I can keep that, save it, and check that later on, or send it to someone to verify that I have really made that transaction. So here is the block which included my transaction. So if we go to that block, we can see that includes 56 transactions, and one of them is going to be mine. We can see here that the amount of gas that was used is 95%, which means that the gas limit that the network allows, which is 30 million, is almost full, which means that the block is pretty well utilized. And this is the thing that I was explaining, why you cannot run infinite loops, basically. Here we can also see that the block reward is 0.03 ETH, which is the fee that is paid to the miners. Here we can see the fee recipient, which means that probably this is the address who created the block. I think this network is already proof of stake, if I'm not mistaken, which means that they're no longer miners, but they are validators. So instead of some of you, I guess, have heard of proof of work. That's the way blocks are being found by investing physical electricity to suggest new blocks and to create them. But now with proof of stake, you basically have to stake your ETH in that case and be part of the validators, and your staked ETH can be penalized or slashed if you want to behave badly in the network. But yeah, that's another story. So yeah, another thing is that here we have an information for the sender and the recipient. Imagine that you're looking on your bank application, bank mobile application, and you see your transactions, and you can see your IBAN, and you can see the recipient IBAN. This is something similar, I would say. Here we can see the value that is sent with the transaction. In that case, is 0.1 ETH. Again, we can see that the transaction fee that I was supposed to pay into the validators in order for my transactions to be included in the block. Here is the gas price, and here is the gas limit. So the fee is the product of multiplying the gas limit, which is 21,000, multiplied by the gas price, which is, as you can see, 3.37 GWh. And here we can see the input data field. That input data field will not be empty if we are interacting with the contract. We can see such kind of transaction, let's say here. So here, the sender is some address similar, some account similar to mine from MetaMask, and the recipient is a contract. So here we can see the input data. If we see the original data, it's basically unencoded data, and this is the data that is supposed to be sent to the miners, and then to the validators and to the nodes, and they are going to take that data, decode it, and execute the instructions that are coded in the smart contract. And here, for example, Etherscan have this cool feature, which is decoding the input data in some human readable way. So here is the function that has been called, which is deposit, and it accepts 3 parameters, 2 addresses, and 1 amount. And here we can see the encoded address, which is 15 BF, etc., etc. The second parameter is address, which is the address 0, and the third parameter is the amount. As you can see, the data is encoded in such a way that it's always padded to 32 bytes, because the EVM operates only in 32 bytes. So every variable there should be padded to 32 bytes. And this method ID is basically the signature of the function, which is the result of the hash of the function signature. So if you apply a hash function to the deposit, to that function signature, and you take the first 4 bytes, it should be these 4 bytes. Okay, I guess this is again a quick intro to Etherscan and MetaMask. MetaMask, as I said, is a browser extension, and its only purpose is to manage your private keys and manage the private keys in a secure way. And the most used feature, and I guess the biggest feature, is that allows applications to send requests to MetaMask through injection. So basically, MetaMask is injecting code into our application, and we can use the MetaMask functions to interact with the network. So for example, and of course, the private keys are never exposed to the applications. So we can safely use this to interact with any decentralized application, or any application that is supporting MetaMask. So the way MetaMask and the applications are talking to each other, as I said, MetaMask is injecting code into our application, and if, let's say, we go to the console and we type window.ethereum, we are going to see that we have this object that is defined by MetaMask. And here are all the functions that we can execute. So we have a flag that is saying, hey, this is MetaMask. We are connected to chain ID 05, which is the chain ID of the test network that we are connected to. Then we have methods like send, request, what is the active address at the moment. There are some event listeners like handle account changed. So we can basically listen, our application can listen to events if I go to my MetaMask and switch my account. So if I switch to this account, immediately my application is notified, and it's no longer connected to my first account, but to my second account. So if I switch back to my first account, my application also switches to the first account. So yeah, basically MetaMask is our entry point to interacting with the Ethereum blockchain. Not only the Ethereum blockchain, but but all EVM compatible chains. As long as a chain is fully EVM compatible, MetaMask can be used as an entry point to that. Let me go through the questions first, and then we can move on. Okay, there are no questions. Do you have any questions so far? Do you want me to talk slowly or faster? Is it okay? Is there anything that I didn't explain well or needs repeating?
I think it's perfect,
Okay.
Darcy.
Okay, cool. Now I'm going to share my Visual Studio screen so we can actually go through the code. Can you see? Can you see it?
We can.
Okay, cool. How do I close this? Okay, so for the purpose of the demo, we are using Web3 Onboard, which is a very nice third-party application that is wrapping and making our life easier to allow our applications to use different available wallets out there. One of which is MetaMask, obviously. So Web3 Onboard is an open source third-party application that allows us to very easily integrate and embed different Web3 wallets into our applications, so our users can use them by their choice, and yeah, they can do all the stuff that we are allowing them to do with these wallets. And yeah, the important thing that we need to remember is that the wallets are basically managing our private keys, and they are allowing us to execute transactions. And by executing transactions, I mean that the wallets are using the private keys to sign those transactions and broadcast them to the network. And in order to be like confident in such kind of wallets, at least they have to be open source, so we can verify their code and make sure that they manage the private keys in a secure way. Otherwise, if someone have access to our private keys, basically they have access to our accounts and our wallets. Imagine someone having access to your mobile banking application. They will have access to all your funds. Of course, there's some 2FAs and so on and so on. But yeah, so keeping our private keys safe is our top priority whenever we have to deal with any Web3 application. So yeah, Web3 on board is, as I said, is a very nice third-party library. It's composed of multiple different modules. The core module, it has modules for React and Vue. And since we are using Next.js for the demo, we are using the React module. And then we have another package, which is injected wallets. And this package allows us to support any wallet that is working through injection, like MetaMask, because MetaMask is not the only one that behaves the way it behaves. There are multiple different options like Rabbi, Tally, or Liquidity. So all of them are under the hood of injected wallets. But for the purpose of the demo, we are going to work with MetaMask. So first, we have to create a Web3 onboard provider and wrap our main component. And whenever we wrap our component, we have to pass an Web3 onboard object. And this is basically initializing the library, saying what kind of wallets we want to support, what kind of chains we want to support, and some metadata, which is going to be displayed in the pop-up when we have to select our wallets. As you can see, we have configured two chains. The first chain is the Ethereum testnet that we are using, Ethereum Go Early. We have to specify 4 different things. The first thing is the ID, the chain ID, which is 5. I'm going to quickly explain what the chain ID is and why it is needed. So because there are so many different EVM chains, and because the assumption is that many people are going to use the same accounts on each different EVM chain, and the assumption is correct because that's the way it is right now. There is a need for some unique property for the chains to be differentiated, because if there is no such property, let's say that you are signing a transaction with your private key on the Ethereum network, and the result of the signing is a signature. But if you sign the same data with your same private key on another network, the signature will be the same. So basically, if you sign a transaction and broadcast on the Ethereum network, someone can see that transaction on, let's say, the Polygon network and broadcast the same transaction without your knowledge, because everything is public, and they can basically take your signed transaction and broadcast it on a different network without your knowledge. So basically, the chain ID is used whenever you have to sign a transaction, and that's why you cannot replay a transaction that happened on one chain to another, because all EVM chains have different chain IDs. Okay, so yeah, we have we currently, our application is going to support the Polygon mainnet network and the Ethereum Goerli network. The chain ID of Goerli is 5. The token is GETH. This is a label where we are going to display for our native currency for that network, the label for the network, and the RPC URL. So the RPC URL is probably the most important piece. It's a URL to a node that is running the Ethereum blockchain. It's running an Ethereum node, and it's accepting transactions, broadcasting transactions for us. So this is actually our entry point, and this is where all of our interactions are going to go to. So whenever we have to, let's say, fetch some data from the blockchain, we are making requests to that node. We can run our own nodes at home or on some VPS or on the cloud, and we can use our own nodes, but also there are some publicly available nodes. There is also one service called Infura, which is providing nodes for usage from applications. They have a free service. They also have a paid service, of course. But yeah, the free service is more than enough to play around and even have some small amount of users. And again, for Polygon, we have the chain ID, the name of the native asset, a label for the network, and the RPC URL. Then we have an array of wallets. So we are basically saying we want to support all injected wallets that are available out there. And the way our application and the way the library detects such kind of wallets, they are looking for window.ethereum. So if window.ethereum is defined, this means that there is some browser extension that serves the purpose of a wallet. And the init function of the onboard library accepts the array of wallets that we want to support, the chains that we want to support, and the metadata. Now, our main screen that we see out there is basically composed of 2 buttons. The first button is the connect button, and the second button is the send button. Now, onboard also give us a nice hook that we can use. So the hook gives us a connect function, a disconnect function, and an object that contains the information about the wallet, and a flag that tells us if we are in the process of connecting or we are already connected. And here we are creating a provider which is using the injected wallet or the wallet provider that comes from the library to initialize such kind of provider. We are using a very famous and very popular library again for that, which is called Ethers. Ethers is probably the best SDK out there to interact with the Ethereum network, or let's say EVM networks. So they have a lot of modules that can be used. Recently, it was split into different packages in order to support tree shaking. So you have to no longer import the whole library, but you can import only the parts that you need. The available documentation is very well maintained and written, so you can check it yourself. But basically, this provider is wrapping the injected web provider, and it gives us a nice functions that we can use, because otherwise we'll have to encode the data ourselves. We have to do everything ourselves. So the library basically makes our lives easier by handling all of the low level stuff that we should not really focus on and we should not really care about, because at the end of the day we need to do to make our application working. Back in the days, whenever this whole thing started, none of these libraries were available. So basically you had to do everything by yourself. You had to encode all of the transaction parameters. You had to sign them manually, and you had to broadcast them manually. And now all of that can be written with this single line ethers provider get signer, which gives us an object that has the private key in itself, or has the capabilities of signing a transaction. And we simply say send transaction, passing the recipient address and passing the value that we want to send. So the recipient address is currently hard-coded. It's my second address on MetaMask, and the value is 0.0.1 ETH. Now, you may wonder why there are so many zeros. The reason for that is because 1 ETH is equal to 10 to the 18. The reason for that is because in Solidity, there is no way you can, there is no support for decimal places. So in order to represent decimal places, you have this thing called decimals or magnitude. So if you want to have 1.2 ETH, you have 0 points, and that's basically 1.2. If you have 0 points, then you will have 57,4,536 with the correct number of zeros. That's like 0 point multiplied by 10 to the 18, and this is again 1.2 multiplied to 10 to the 18. A quick stop to see for any questions. Okay, I guess there aren't any. And yeah, again, we have a button which is saying if there is a wallet, then we can assume that the wallet is already connected. So we can execute the disconnect function. But if there is no wallet coming from the hook, this means that the wallet is not connected. So we are calling the connect function. And again, we can check whether the connecting flag is up, and if the connecting flag is true, this means that we are currently in the process of connecting. Otherwise, again, we want to check if we have a wallet, and if we have a wallet, we display a disconnect label. Otherwise, we display the connect label. And the other button, send, is checking if there is already available ethers provider, and if there is available one, then we get the signer and sending the transaction. Now we can try and add few more options to our application, few more wallets. So our users are going to be able not only to use the injected wallets like MetaMask, but they will have other options too. In order to do that, I'm going to use the GitHub of the library. And here is the full list of wallets that are supported. So we have Coinbase wallets, we have the injected wallets, which is again, it's not a single wallet, it's multiple different wallets, but they are under the same hood. So we have Coinbase wallet, we have Wallet Connect, we have Gnosis, number of different options. We also have hardware wallets. So our application can support also hardware wallets. I think this is the most secure type of wallets, because they are a device that is storing the private keys, and the private keys never, so something like that, a ledger. So the private keys never leave the device, and the application is making requests to the device. So the device has a little screen, so you can verify all of the parameters of the transaction request. And if you are satisfied with them, you can choose to accept or reject the transaction on your device. So whenever you have to, let's say, accept the request, you are clicking a button on the device, then the device is signing the transaction data and sending back to the application the signed transaction, and the application can broadcast the transaction. So basically, the security of this is unmatched, and the reason for that is that the private keys never leave that device. They are never exposed to the internet in the Chrome store or Chrome storage, or in the case with browser extension or whatever. So yeah, let's try to add a Coinbase wallet. A Coinbase wallet is a wallet built by Coinbase. So for that purpose, we want to have this library. And now I will share my whole screen. Okay. So we have to add this library. Then we already have the core because we need it. Then we can go to the place where we are initializing all of the supported wallets. And then we can say our Coinbase wallet is going to have the only configuration that currently we want to support is that we want to be in a dark mode, but there are plenty of options that we can have. Then the only thing that is left to do is to actually add it in the array with wallets. And now, if everything was all right, in the pop-up, we should now see Coinbase wallet. And because I don't have it installed, whenever I click, I'll be asked to install it by either scanning the QR code or installing the extension from their website. Okay, and one more, and I guess we can move on to the Q&A section. Then we have Wallet Connect, another great example. Wallet Connect is a very good, I would say, protocol that is allowing us to connect our mobile devices with our applications, and we can confirm or reject transactions through our mobile devices. And again, we need the Wallet Connect package, so I'm going to add it. Then we need to initialize the object responsible for Wallet Connect, and again add it into the array with wallets. And now I haven't included that. So now Connect, we also have the option to choose Wallet Connect. But Wallet Connect, as I said, is a little bit different, and we need to have our own server that is serving as a bridge between the devices. And because we don't have such kind of server at the moment, we cannot connect. But yeah, MetaMask is always an option. So okay, I think that was what I planned to show you and to from the first lecture. So if you have any questions, yeah, let me check.
Thanks, Kasi. I see one question. Does it mean that any malicious browser extension or any JavaScript dependency can get access to your MetaMask wallets and do anything with your money?
That's a good question. And for that, I'm going to lock my MetaMask. So I'm locking my MetaMask and I'm asked for a password. That password is used to encrypt all of the sensitive information. And actually what is stored in the Chrome storage is not, a plain text of my sensitive data, but it's actually encrypted with my password. So as long as you have a safe password, and as you can see, mine is not that safe, you are good, I guess. But yeah, if you have any malicious browser extensions, they can probably do some kind of middleman attack and modify the transaction data that is going to be sent or something like that. But MetaMask have come up with this nice tool. I forgot the name, but I'm going to check it, which can give you a heads up in the MetaMask browser itself. In the MetaMask browser extension itself, it can tell you if you have a malicious extension or not. Yeah, I forgot what was the name, but I'm going to check it and I'll leave it in the resources. Thoughts about Luna? Well, what can we say? I mean, Luna was probably a scam from the beginning, but a really well
Hidden.
hidden, yeah, a really well hidden scam, because a lot of people didn't realize that it was a scam until it happened. Although there were many people that were knowing that it was a scam, and they were basically always saying on Twitter that this cannot be sustained and it cannot be sustained too much longer. But they were all like rejected, and they were all like,
actually, for anyone who can read smart contracts, it was obvious that it's not sustainable because the collateralization in Luna was about 30% of the assets that you can withdraw, while let's say the collateralization in MakerDAO is 170%. And that's why MakerDAO is still alive. And this was the main reason why Luna failed. And for all the people that really understand of blockchain, that was obvious, and they didn't lose money there because they didn't use that service. Regarding Celsius, that's a centralized platform, and that's the problem with the centralized platforms. They can always disappear, or something bad can happen to them, and that's why we're developing decentralized systems that tend to be more secure and transparent. Krasi, we have some other questions in the chat.
I can see it. Yeah, the question about the source code and the tools.
No, the question about the backend. They ask if everything should go to the front end. No, you can use the same libraries, like there are lots of Web3 libraries that you can use on your Python backend or JavaScript backend or Java backend. Same operations, since we communicate with the Ethereum blockchain and like to a node by a REST API, we can use any programming language and any environment to communicate with the blockchain.
But what about MetaMask? MetaMask is browser extension. In the case of interacting through blockchain through backend, should we use different type of wallets?
MetaMask is not using a backend in the way we think of backends, but they are using like Infura, which I mentioned once. It's a service that is giving us access to EVM-based nodes. that we can interact with. But MetaMask have some backends that are related to their swap experience. If you go on the mainnet, you have the swap functionality, which basically allows you to swap between two different assets, and they are using some backend endpoints to calculate the routes, the best routes.
But I assume the question was if
Where
you
is the
need
private key?
to sign a transaction, right?
Okay. Where is the private key? Yeah, the private key is not on a backend. Thank God. It's in the Chrome safe storage. I'm not sure how safe it is, but again, whenever you enter your password, you encrypt your data, and your data is saved on your browser. So if I delete my browser, I'm going to lose all of my MetaMask data. And in order for me to restore my account, I need to know, I think we didn't mention that. We need to know our seed phrase, which is 12 words. I'm going to share them because that's account is for the demo only. As you can see here, the red button, it says reveal secret recovery phrase. So this secret recovery phrase is composed by 12 words. It could be also 24, but in that case, it's 12 words, which are like basic words. And those words can be saved or copied or copied on a piece of paper or on some very secure storage. And whenever you have those 12 words, you can use them to restore your account if your PC dies, if you delete your browser, if you delete the extension.
Also to restore your private key. And Alexei, once you have your private key, you can even hard code it on the backend and sign transactions with it. So typically when we do backend applications, we either keep the private key somewhere on the backend, or we can keep it on AWS keychain or some other special services for that. But at the end, it stays in our computer, or it comes to our computer at some point to sign a transaction.
So you don't need a wallet. You
No.
You can sign transaction from a backend. You just need to have a private key there, and there are certain approaches how to store them securely.
Yeah, and the private key is the wallet. Basically, all these wallets, they're just an interface which hides your private key somewhere inside. But if you have the private key, you have access to your wallet, which lives on the blockchain. Your wallet is not on your computer. Your wallet is in the blockchain, in the cloud. And with this private key, you can operate with it. So it doesn't matter how and where you store it. As soon as you have the private key, you can operate with a given wallet.
Yeah, and to expand on that, basically the blockchain, the only thing that the blockchain keeps track of is the public addresses. So if we go to Etherscan, the only thing that the blockchain does is to keep track of the balances of each account, and these accounts can be accessed through the private key, as Christo said. So if you have access to the private key that corresponds to that address, then you can manage the balance that's stored in the blockchain.
And if you have the private key, you even don't need to know the address.
Yes, because the address is derived from the private key. You have the private key can give you the public key, and whenever you apply some hashing functions on the public key, you get the public address. And to get back to the question, do you need a wallet to broadcast transactions? No, I think the most secure way someone can interact with the blockchain is even in a PC or on a device that doesn't have access to the internet. It only has the private keys. You sign the transaction with that air-gapped device, then you get the signed transaction, and you go to a PC that you can interact with the internet, and you broadcast the signed transaction. That
But
way, the private key never.
How
never
do you
leaves
move the transaction to another PC? Can you put it on
I
a
don't
flash
know,
drive?
Flash drive or something like that, yeah. Or you can even type it.
The whole hash.
Symbol, but the whole hash, yeah. But that's too extreme. I mean, in order to have a broad user adoption, we need to think about the user experience, and that's why we have things like MetaMask and all the other available wallets out there. So if I have a...
There is a question, do private keys go via network to call smart contracts? No. Karasi can explain that. We never send a private key to the network. We send only the signed transactions.
Yeah, again, the private key should never leave your possession and should never be leaked in any way. It should never be sent through a HTTP request or I don't know. It should never, it should never be made possible for someone to see your private key. The only thing that you do with the private key is to sign transactions and messages and use services to broadcast those transactions. And it's all based on private public key cryptography. So you can not only sign transactions and broadcast them, but you can sign certain messages. Let's say you can sign a message and you can send the signature, and the recipient of that signature and the message can verify that you actually signed that message. So a nice use case for that is whenever you have to, I don't know, sign a document and prove that you have signed it. This is a good way that you can do it. So you can use your wallet not only to interact with the blockchain and make transactions, but you can also prove ownership or prove, I don't know, prove that you have done something. About the question of Denis Sukov, I'm going to zip the source code, or even I just send a link to a GitHub repository with the source code and link to the tools. There is no special environment that you need. The only thing that you need to do is to install the dependencies and run the project as any other React application, and you're good. If you want to play around with smart contracts and get into development, you can use this web-based development environment called Remix. It allows you to develop Solidity code and compile it, even deploy it locally on your browser and interact with it. On the next lecture, we are going to use that for developing some smart contracts and interacting with them. So if you want a heads up, you can use that and try to play around with it.
Awesome. There's a question regarding if it works with .NET, with TypeScript, with JavaScript. It works with all languages, guys. It's an API, and there are libraries for all the languages, since that's becoming a very popular kind of application development. So you will find a library for your favorite language for sure.
Yeah, basically the way you can communicate with the blockchain is through gRPC. So as long as you can send gRPC requests to that node, you can use any language you want. I mean, you can use even C, I guess. But yeah, I think the most used one is JavaScript, TypeScript, just because there are many available tools and many available applications already built on that. And obviously the web is built with JavaScript, so most of the libraries are focused on JavaScript and TypeScript.
I see more questions coming, but we're running out of time, so keep your questions for the next lecture. There is no homework for now. We'll send an email with all the materials, code snippets, recording from this and everything, and you can go to these things as they will give you lots of additional information about what we talked. And maybe a last one, what do you think about always developed Ethereum killers? That's a great question. For me, it's like the always developed Google killers or Microsoft killers. Like there are many attempts, but so far no one successful.
I think that the term Ethereum killer came up in 2016, and as you can see, 6 years later, Ethereum is still on the top. So yeah, as Christo mentioned, it's not gonna work.
All right, so thank you very much, everyone, and stay tuned for the next lecture next week. Keep also your questions for then. Have a great day, night, morning, from all around the world.
Krasimir, thank you so much for a great lecture.
Yeah, thank you too, guys, for attending. Yeah, see you next week.
See you, everyone. Bye.
Bye.